they have assembled each and everything, and even in fact they launched the vehicle without simulating the actual environmental conditions on some parts, not every part, on some part. After some time, maybe after 3 months or after like some 2000 kilometers, there was a problem with the headlight of the bike. It was getting, cracks. Then it became a big issue. Once you launch the product and you have any kind of issue, then it will be a big problem, particularly whenever we have a mass production. Then the R&D and quality manager, concerned persons over there, they called us and they discussed, this is the problem we are facing right now. And we have very big issues nowadays because we have produced thousands of bikes, and everywhere, wherever we go, we have this complaint from our dealers, from our suppliers. So please let us suggest how we can, come out from this problem. Then I have analyzed each and everything and come to a conclusion that you have not tested, you have not simulated the actual environmental conditions which our bikes are facing in the, when it comes to the road. So we have collected all the data and then amplified the data some 2-3 times and suggested to them to go for a electrodynamic vibration shaker system. Because earlier what they were doing simple mechanical type of vibration test rig, like which is having maximum of 250 Hertz. Then I suggested to them to go for electrodynamic vibration system and capture the actual data on the road and simulate it by amplifying some 2 times or 3 times. They procured the system and did the same thing, and they the test given number of outputs to them. After that, they have changed the design, they have changed the material, they have changed the fixing arrangement, lot of things they did. And all those things, this vibration machine only told to them that you need to do this one, this one, this one, this one.
Hello, sir, Arun, sir. Sir, it's training. Webinar. Where are you sitting, sir? Your
Then they have thanks like anything
coming there or
to us, and after that they had given some 3-4 orders
no, sir, your
for the vibration test systems. Can you please mute? Actually, I have some background noise.
Yeah, welcome. You are there.
If you don't mind.
Hello.
Even in fact, they have one plant in Indonesia for this two-wheeler. They procure one system from us for that plant also. So I mean to say, till we should not till we should not simulate the actual environmental conditions on any kind of product. Doesn't matter if it is related with the automotive industry, or it is like avionics, or it is, electronics, or it is any kind of product. So it is very important to simulate the actual environmental conditions before launching the product. So on that one, we are discussing particularly on the vibration test equipment. What is the effect actually when we are designing a product in terms of cost? It is like when it is in design phase, it is costing very less, somewhere around 40,000, 50 rupees. When it comes to the procurement stage, the cost increases, and when it comes to the production level, it comes up to 400. And before shipment, it is like 16,000. And when it comes to the customer end, because it is the cost of the product goes like anything, because lot of things got involved in this, like production, R&D, shipment, transportation, lot of things. In case we have any kind of failure at customer end, then it becomes a very big challenge. So that's why we need to do the vibration testing. Like we need to simulate all environmental conditions before concluding to the product at final stage. So there are number of stages like the design stage, production stage, after assembly and then final. There are a number of stages where we can do the environmental testing, this vibration test. So this is a cost effect actually, which impacts the product. So it is always better if we can design our product and test it, simulate the conditions so that we should not have the problem when the products come to the customer end. Now, if we are talking like what are the environmental conditions we have on the earth here? Sorry. And what are the effects of different environmental screening conditions on the product? So major conditions is like temperature cycling. Like we have product which is, we are using at minus 20 degree also, and sometime it is going up to 60 degrees, sometime it is 70 degree, and when it comes to the automotive kind of component, the temperature is going more than 120, 130 degree also. So what is the impact of temperature? That is the main important over here. So the main, if we are talking over here, it is like temperature. Temperature is having a big impact on the product. After that, there is a vibration, random vibration, then high temperature, extract screen, thermal shock, sine vibration, fixed frequency, then low temperature, sine vibration, sweep frequency, combined environment, mechanical shock, humidity, oscillation, altitude. So these are the ranking of the environmental conditions which impact on the product. When we are talking about the percentage of the failure on any kind of product, then it is like vibration stress, it is somewhere around 45%. It is compared to all other effects, failure percentage, it is very much higher than others like temperature, hot and cold, and the others. And 20% is like combined environmental stresses. Nowadays, the trend has been changed. Whenever we have product, we are not only simulating the vibration, we are simulating the combined condition, vibration, temperature, and humidity, and sometimes altitude also. When we are discussing about, defense kind of products which we are launching, like Arsenal. So in those conditions, we are suggesting and we are simulating combined environmental stresses, including altitude. So percentage-wise, if we see over here, the failure percentage by vibration is very, very high. So that's why it is very important to have the vibration testing before producing any kind of this final product. These are the environments found on the earth actually. We are very much aware about all these like cold, rapid temperature, altitude, sand, dust, corrosion, solar radiation, raining, muddy water, altitude, vibration, combined and vibration. So these are the environments generally we have and we are facing day by day.
Okay, teams meeting today.
Now we will, I think most of the guests over here, they are very much aware about the vibration testing. Some of them, they are already doing the test. So they are very much familiar what is vibration test and how they are simulating the things on the product. As we discussed, why this vibration testing is important. We already discussed on that. It plays a very crucial role in the product development and quality assurance, just like detecting structure weakness. I given an example of TVS. There was a lot of issues, particularly with the structure. So they have modified that and come out the problem. Then product reliability and compliance with industry standards. There are a lot of industries who has their own test standards, and they are, qualifying their product as per their norms, testing standards. Then in case we have all these kind of testing before launching our product, then there will be very less problem, particularly when we are talking in warranty period as well as after warranty. So that will give the confidence to the customer. So that's why this vibration testing is very, very important for the product what we are manufacturing. When we have a requirement of vibration test, the important point is like how we can select a suitable vibration test equipment. What are the important factors? What are the important parameters which will guide us to have a suitable, capacity and suitable subsystems along with the vibration test equipment. So there are some factors over here. First of all, we should know what kind of test we want to conduct. Like there are, different type of vibration test, like sine vibration test, random vibration, sine on random, random on random, SOC, SRS, RTH, LTH. And sometimes users, what they do, they simply capture the data from the road and apply to the product. Just amplify 2 times or 3 times and apply to the product. So there are different type of vibration test. First of all, let us decide what kind of vibration test we want to do. Particularly when we are talking defense industries, we are generally following JSS Penta 5 as well as MIL 810 test standards. So in those standards also we need to see what category and what level of the vibration. These standards are very clearly defined the category of the product. So according to the category of the product, we need to see what is the level of the vibration and what is the frequency. So these are the important parameters related with the type of the vibration test. Now this frequency range also comes into these parameters. These standards clearly define the frequency range, high frequency as well as low frequency. Then third important parameter over here is payload capacity. We need to see the product what we want to test, what is the capacity, what is the weight, of the specimen, including fixture. That is very much important actually. Without knowing the maximum weight of the product along with fixture, we will not be able to decide a suitable vibration test system. And fourth important factor is what is the acceleration level and amplitude of the test we want to conduct. And sixth important parameter is like sometime we are doing R&D kind of activities. That vibration testing is not only the criteria for our product. We just do the vibration test and after that we will test our product. If after vibration it is working fine, then it goes for no. Sometimes we are doing a lot of R&D kind of activities. So we have to, see the response. We have to see the response of the product, how it is behaving. When for example, in case we are giving 1 G input from a frequency range of 10 to 2 kilohertz, what is the output of the product at different part? So we can mount some sensors for monitoring. and we can record all those data and we can analyze and we can see this particular part is giving a lot of like resonance or anti-resonance, dumping, anti-dumping, this thing, that thing. A lot of things we can see by recording all those test data, and accordingly we can modify and we can improve the product design and the structure or whatever it is. So it comes to like how many control channels and monitoring channels we need. For example, in case we have very huge kind of like racks and all, which is having number of equipment inside it, and we want to see the behavior of each and every subsystems what we placed inside the rack when we are transporting this rack from one place to other place. Then we can do that by mounting the whole rack on the table and by mounting the sensors at different subsystems and running a profile. So that way we can see, yes, this particular area is having very high vibration and it can cause problems over there. So we can modify the like assembling kind of activities, assembling kind of things over there. So accordingly, this I have given a very simple example. When it comes to the a defense kind of products, there are a lot of other high level, high-end monitoring and analysis things. So the number of channels of the vibration system depends the type of product and the type of testing. What kind of testing, analyzing we are going to do. So this is very important. We have to define what kind of testing we want to do. That is important. Then only we will be able to see, we will be able to decide this is the equipment we need to fulfill our requirement. Once our requirement is final, then we will think about the vibration. Carrying conductor, current carrying conductor, it is sensing a force, and the direction of the force will be according to the direction of the current. When we are giving, for example, when we are doing like sine vibration test, sine it starts from 0, it goes maximum, then it comes to 0, then again negative side maximum, then it comes to 0. So it is a alternate signal. 0 maximum positive, then 0, then negative maximum, then 0. So according to this, we have a force which allow the movement of the conductor inside the magnetic field. So this electrodynamic vibration system work on the Fleming's left-hand rule of electromagnetism. Now, these are the selection guidelines, vibration shaker system selection guidelines actually. Here, the major important parameter is force rating of the electrodynamic shaker or any shaker. And the force rating, we need to calculate according to the test level in terms of acceleration, and the mass, total weight of the DUT along with the fixture. And force is equal to multiplication of mass into acceleration. So force rating is very much important. First of all, let us decide the force rating of the equipment first. And that is very simple. Let us calculate the total mass which we want to test and what is the maximum acceleration level we want to test. Just multiply both. It will give the force rating of the electrodynamic shaker system. Like force requirement, as we discussed, that first we need to calculate the mass, and mass will be UUT plus fixture plus internal armature mass, moving mass, and multiply by the maximum level acceleration. And then for safety point of view, you can multiply it by 1.2 or 1.3. That will give the desired force rating. Then the maximum displacement and maximum velocity. There are two other important parameters, maximum displacement and maximum velocity. So these depend upon the test. Sometimes we have like very high displacement kind of testing and G also. So that required high velocity. So is our system what we have? It is compatible to give that much displacement as well as velocity. So this is simple actually. This is like main thing is over here is the force, and along with force rating we are just discussing displacement and velocity. So according to test requirement we can define the velocity as well as displacement. Same thing, moving mass F is equal to m into a, determining moving mass. The mass in F is given must include all moving mass attached to the Shaker armature surface, including the armature mass itself. Shaker armature, head expander, slip table, and drive bar, test specimen, interface fixture, including bolts, bearing, this thing, etc., etc. That will be the total mass. Then this is also very important parameter here. The product, what kind of shape of the product we want to test. That is also important over here. Like, what is the dimension? What is the CG, center of gravity of the product? And how we are mounting that product with the fixture. So that is important, because in case we are not keeping the CG of the product with fixture in the center of the equipment, then it will be having a lot of issues with the armature, that moving internal part of the machine. To avoid that CG problem, we should have like a guided kind of platform, so that it should not impact directly on the armature. So this is also very important, what kind of specimen specific we have. So that also we need to consider while we are selecting a vibration test equipment. These formulas are very simple formulas. I think most of you may be knowing that velocity is 2 pi f, d acceleration is 4 pi square, d divided by 98180. V is velocity, A acceleration, F you can see, D displacement. Now, we are discussing how we should have a smart vibration lab. Nowadays, actually, trend has been changed. Earlier, we had this equipment here, that equipment there, and we are doing testing here, there, this thing, that thing. Now the things have been totally changed. Now it become very advanced, integrated, and different kind of things. We should have a combined environmental test lab, and the combined environmental test lab, which is having all kind of equipment. It may be having vibration machine, it may be having environmental chamber, and then pump test, soak test, centrifuge machine, thermal soak, etc., etc. So each and every time we need, see, some of the equipments we are using to test number of hours, 200 hours, 100 hours, 300 hours, 400 hours also. So each and every time there is no need to go to the lab and set each and every equipment is according to this. because there will be a lot of interruptions over there. Power failure, this failure, that failure. So in that case, what we have the solution, we have like a smart vibration test lab along with other equipments, where we have equipment at one place and we have a control room at other place. From the control room, we can like monitor each and everything what is happening inside the environmental test lab. And even we can control, including test start and stop, monitoring other safety parameters. We can do whatever we want to do by setting a control room. There is no need to go again and again for each and individual equipment to the main test lab. So that kind of facility we have developed and we are, delivering to the customers. So all these parameters, what we are discussing over here, so we can control all these things remotely. Automated data dashboard is there, where we can monitor even safety parameters and input parameters and test parameters. All those things we can monitor over there, and we can have a lab in a proper way. So these are the features of the smart lab what we have. Centralized console control cycle, SOC and pump tester, which we are communicating through the internet and our proprietary buses, software profile and schedule, acoustic insulation of lab. So this kind of remote access we have of the complete environmental test lab. By sitting in a control room, we can do whatever we want to do. These are the key factors. This advanced laboratory, what we are going to have. Now again, I come to the selection of the electrodynamic vibration signal system, and I have given one example over here, just to have a suitable vibration test system. For example, we have a test requirement which is having a frequency range of 5 to 2 kilohertz, and the vibration level from 12 mm displacement and 10 G. And DUT weight along with fixture is somewhere around 50 kg and size is somewhere around 400 to 700 into 400. So when we have this test requirement, let us see what kind of vibration test machine will be suitable to fulfill this test requirement. So here let us discuss the platform size first. Since the DUT size, it is 800, 700 and 400 along with fixture. For mounting this DUT, we should have at least minimum 1000 into 2000 mm platform. And when we have a 1000 to 1000 mm platform of magnesium alloy, which is the lowest weight material, the weight of the platform will be somewhere around 120 kg. Here it is very much clearly defined the level of the vibration here, which is 10 G. So now if we put the formula like, if we calculate the total mass Total mass will be 120 kg is the platform weight, 50 kg is the DUT weight, and plus internal weight of the shaker. That's called armature. So it comes 170 into 170 plus armature. Now, as per the formula we discussed above, the force is equal to mass into acceleration. Mass is equal to 170 plus armature into acceleration level is 10 here. So it comes 1700 plus armature into acceleration level here. So now this is the effective force. We forget about this armature. The effective force is 1700 kgf, which is required to test as per the requirement mentioned over here. So let us assume this, because the effective force is 1700 kgf, so let us assume a 2000 kgf shaker system will fulfill the requirement. The armature weight of 2000 kgf will be approximately 20 kg. If you put the actual values and to calculate the required force, 1700 is the effective force plus 20 kg is the armature and the level of the vibration is 10. So this becomes 200. 200 plus 1700, it is 1900 kgf. If we put like 20% safety factor over here, so 20 or 30% safety factor over here, it becomes 470 kgf. So it means an equipment which is having a capacity of 2500 kgf will fulfill the requirement of our this test. Yeah. So this way we can calculate the capacity of the equipment according to the requirement. As we discussed, what are the major specifications of the vibration machine? First, like force rating, which we already calculated in the previous screen. Then second one is maximum displacement, velocity and acceleration. Then armature dia, frequency range, load capacity, power amplifier capacity, and number of channels, control channels with the software, sine, random, so RSTD, what kind of test we have. So these are the important parameters over here. And according to the number of channels we are selecting for vibration controller, we should go number of accelerometers. Then according to the size of the product along with fixture, we should, decide. We should have the size of the slip table for X and Y axis. And similarly, for vertical axis, size of the head expander. So these are the key factors of the vibration shaker system values. And sometime in case we have a combined vibration test requirement along with the environmental chamber, we should have like thermal barriers. These are general type of testing applications like milli-standard, sine random, so sine on random, JIS, IEC, ISS, CQM, vibration OEM standards, transportation simulations, production testing, product development and qualification testing, design analysis, environmental stress screening, fatigue and stability testing, buzz, squash and rattle. This is very much important for the four-wheelers actually. This last test, four-wheeler manufacturer and four-wheeler manufacturer vendor. This is like very different type of test. If any automotive guest available over here, he can discuss in case he want. Now, this is our product profile actually. We have product from 5 kgf, like 50 Newton, to 20,000 kgf, air-cooled as well as water-cooled vibration system. We have like more than 300 equipments already installed in India as well as in overseas market. We are exporting to like Australia, Canada, France, Indonesia, Malaysia, and Vietnam. and Saudi Arabian countries. This is the equipment actually we have supplied here. This is for defense application. This combined electrodynamic shaker with environmental chamber here. The left side, this is the equipment which is having all environmental conditions. All environmental conditions mean like vibration, humidity, temperature, plus altitude. There are two equipments we got installed. One is in RCI Hyderabad and second one is TBRL Chandigarh. This is totally different. Design of the equipment is totally different here. Then this second right side equipment, very recently we installed in one test lab in Canada. Then these are the switching power amplifier we are using along with this electrodynamic vibration shaker system, and we are very much capable to produce a power amplifier up to 280 kVA. Which is very much suitable for 20-ton vibration shaker system. And the advanced feature of the equipment is we have HMI based complete user interface. User interface control system and very much sophisticated. And we have like auto resume kind of facility also, because nowadays if in India if you see, power failure is the main important problem over here. The equipment what we have, it can be auto resume in case there is a power failure and the power comes. When the power comes, system will auto resume and start the test automatically from the test when where it is stopped. So all these facilities we have implemented in our system. And these are the latest design of the slip table, horizontal slip table, where we are using like hydrostatic bearings with side supports to avoid the transverse vibrations, and vertical load support. According to the requirement, we can have guided load support, we can have a square, or we can have circular as per our requirement, test specimen mounting requirements. The number of vibration controller, we can choose number of channels, input, outputs, and type of softwares, sine, random, RSTD, random or random, sine, SRSTTH, as per our requirement, we can choose the controller. What we are discussing in a smart lab, so these are the parameters over here actually, these are the screenshots, how we can control the equipment by sitting in a control room. So we have remote control kind of facility along with our equipment. Our each and every equipment can be remotely accessed by sitting in a control room. And it can be like used left and right. We can switch on, we can switch off, each and only the things. Whenever we have like mechanical kind of things for mounting and fixing the equipment, that time only we need to go to the lab. The rest of the things we can control by sitting in a control room. We have like this bump testing soak test machine, pneumatic soak test machine, and our soak test machine is designed up to like the machine what we supplied in Vietnam. It is somewhere around 20,000 G. So we can design as per the customer requirement. We have like from 5G to 20,000 G, and platform from 300 by 300 to 2 meter by 2 meter. According to the requirement, we can design the soak test machine. And it can be combined with bump test machine, soak as well as bump. Both the features can be combined in a single test machine. So there no need to go for a separate bump test machine. Both the tests, soak as well as bump, can be done with a single test machine, single bump and soak test machine. Then we have centrifugal acceleration test machine over here,
Right.
which we have, installed like very prestigious customers like Godrej, L&T, and HCL. There are a number of, even we exported number of centrifugal machines also. So this is also having same kind of features. This can be accessed and controlled through a remote control panel by sitting in a remote control room. Then bump test machine. We have our offices in NCR, Bangalore, Pune, Hyderabad, and Chennai. And anybody can approach us 24/7. Most of you may be knowing our, the customers support, what kind of support we are providing to our customers. This is our website in case you want to know more about us, more about our product.